All right, guys, you may have seen the notice. If you went looking for the March 29 video, wasn't there. At least it wasn't in our list. It's there now. So if you missed that day and you need to review the video, it's there. If there's any homework you weren't able to do because the video was gone, just go ahead and do it and upload it. And as you upload it, type in a little note saying, hey, you lost the video. I couldn't do it. Just anyways, tell me why, why it's late. I'll totally understand. And the loops homework has a question that says, either count up or down based on what the user wants to do. And I've seen some people really come up with interesting ways of handling that. Y'all are trying way too hard, making it a hard problem. I didn't mean for it to be a hard problem. It's totally cool if you do it as a hard problem. But here's what I meant for it to be like, right? Should just type it in idle for the ease of actually getting it, the syntax to come up right. I don't remember the exact problem, and I don't want to give you the exact problem anyways, but it was something like this. Ask the user if they want to count up or down, depending on what they say. Count either from, 1 to 10 or 10 to 1. Something like that. So all you have to do is ask them and then do an if-else or an if-elif based on what they want to do. Something like this. You need a variable to hold your input. Choice is equal to input. Count up or down. Like that. And then we can do an if based on that. Easiest one, the most normal one to our brains, is counting up. So let's do that one first. If the choice is equal to up, then we're going to count up. And I'm just going to use a for loop because I think for loops, the syntax is cleaner than a while loop. So we're going to go up. Then for x in range, we want to go from 1 to 10. I don't think that's what your homework wanted you to do. 1. I can't stop at 10 though because that'll actually only count to 9. So go from 1 up to, but not including 11, skipping 1 every time. And then print x. Something like that. That would count up. And let's see if they typed in down. Elif choice is equal to down in colon. You just do the kind of the opposite. For x in range, we want to start at 10 and we want to keep going down to 1, so we have to go 1 past that. So from 10 down to but not including 0, every time we go, we want to skip by -1s. Make sure that we're counting down. Don't forget the colon, like I usually do, and then print x, like that. And then if neither one of those choices was right, we ought to tell them that they didn't get it right. Right? Print invalid choice, something like that. Just to let them know. That makes sense for those of y'all who looked at it and struggled with it. I saw people trying to make it so that you could use a single for loop, and so that you modified A, B, and C based on, what they chose. And maybe I'll do that real briefly, but it absolutely was not necessary. So let's April 17.
So you would still use x as the for instead of choice?
You could use any variable you want, but yeah, why reuse choice? Right, because choice has a different meaning. It's right. I wouldn't mix my variable names like that. All right, seems to work. Looks like I didn't give any syntax errors. Okay, if you wanted to do it all in one fell swoop, or in a more complicated way that some people were trying, you could do something like this. You'd still need that choice statement up there. And I don't really, anyways. So if the choice is equal to up, then let's define our begin, our end, and our step, right? Because those are the 3 things that change based on whether we're going up or down. So if the choice is up, The begin is equal to 1, the end is equal to 11, the step is equal to 1. You see where I got those numbers? Else, I'm just going to do an else here. I'm not going to even tell them that they got it wrong. Else, the begin is equal to, what would the begin be if we were counting down? What's our beginning point, according to this? Well, 10, right. You had the right idea. And then the end is equal to 0 because we don't want to reach 0. We want to end at 1. And then the step is equal to -1. And then we could write a for loop that counted from using those values. So for x in range, begin, comma, end, comma, step. Print. Counting, comma, x. Something like that. That would do it. I think the first way is clear to our brains. I think. And maybe the second way is clear to your brain. Some people were doing it that way. If that's how you feel in it, that's totally cool. All right. Hope that makes sense. If I was going to ask this question on an exam or something like that, this is what I would have expected y'all to come up with. I'm probably not going to ask y'all to do a decision before your loop, right? That's just kind of cluttering it up a little bit. But I wanted y'all to think it through and take a stab at it. Anybody have typos? I shouldn't only ask for typos. Anybody not having it behave the way that they want it to? So the book goes on about this, which is important if you're using arrays, not so much if you're using lists, which we are. Using a constant as the size of the array. Avoid magic numbers. So you don't want to go in and write something that looks like this if you have an array. Say we have a list. Let's just make a silly list called colors. And it's equal to 3 colors. That's a square brace and not a parentheses. And our color, quote, red, end quote, comma, green, end quote, comma, begin quote, blue. Now, if we wanted to print those guys out, here would be the cheesy way of doing it. For I, index counter, in range, starting at 0, and my length of the array is 3, so okay. That's what I'm going to do. And then I'm going to print out colors at subscript I. Okay, why is that lame? What would happen if I went in and added a 4th color to it? I would have to change the 3 as well. Exactly. So you don't want to use a constant as the length of your array. Excuse me, you don't want a magic number like that. In some languages, you really do need to have a constant declared that floats around in your code telling you how many items are in the array, specifically C++. You could simulate that in this kind of language by doing, I don't know, size, color underscore size is equal to 3. Now, even that's kind of cheaty, but it would be better than what we had before. And then we could change that for I in range 0, comma color 3. We would change it for I in range 0, comma color size. And remember I said that if you're starting off at 0, you can just remove that. So I'm going to delete that 0, comma. All right, that's a little bit better. That's how you would do it in some languages. But in our language, we have the ability of asking the list for its size. That's the best thing to do. So if the list size changes, great. We don't have to change any of our code. And here's how that looks. For I in range, I want the length of the color list. So len, parentheses, colors, Now I've got 2 opening parentheses, so I need 2 closing parentheses followed by a colon. And then print colors subscript I. All right. So the book makes a big deal about having a constant that has the length of the array in it. And that's real important for languages that don't have the ability to spit out the length of the array as we did here. Now Python and Java and a lot of other languages do have the ability to do that. C, C++, not really so much. So when I skip back to the page about constants, keep that in mind. Not so important for us, but I want you to tuck the concept away because you'll be going on to other programming languages, I hope. So avoid your magic number. Declare a named numeric constant to use every time the array is accessed. Great idea, but you don't need to do it, right? Make sure the subscript remains less than the constant value. Well, we did do that here, right? I started at 0 and it kept going as long as it was less than color size. So yeah, you just have to make sure that the index, the subscript, is always less than the length. I'll put a comment to that effect. Index counts from 0 to 1 less than the size, the length. In Python, we get the length using the len function. Like len, you know, whatever your array, whatever your list is called. Here we did len colors. So if we wanted to, we could have done something like this. While I is less than the length of the array, right? We could write our loop a little bit in a lengthier fashion, and I showed you all both ways of writing these kind of loops. So why not? We're going to rewrite this code right here using the while syntax. I'm going to put this above the comments here just to keep it close to the code. So I need to declare my counter, I is equal to 0, and I need to have my test, because these are the 3 things you always do in a while loop: declare, test, and increment, or update. So I is equal to 0 while I is less than the length of the colors list. Print out the colors list at that element, at that index, colors subscript I, and then I equals I plus 1, or I plus equals 1. All right, so these 2 things do the exact same thing. Guess I'll run it, make sure I don't have any syntax errors. Okay, just keeps printing our colors over and over because we did it in 3 different ways. Now for the 4th one. I call this one the for index loop. That is to distinguish it from the loop that I'm going to add next, which is a for each loop. I think I'll just tack it above my while loop here. For E in colors, colon, and that's the word in, not just a letter N, and that's certainly not a 1 there. For E in colors, print out E. In some programming languages, you actually use the word for each. Right, so for each element in colors, print E. Now I think it'd be neat if the Python inventors had put the word each in there, but they didn't, so we leave it out. If I ask you to write a loop to print something out, I don't care which syntax you use. But if you eyeball these, you might come to an opinion about which one you like better. I would really like for y'all to have this one in mind, because when we start talking about lists more, That is certainly the fastest way of typing code that'll process lists, right? You can just eyeball it. How many characters did you have to type to get that to work? How many characters did you have to type to get that to work? The difference is, in this one, we are counting an index counter, an index, and we're using that as our subscript into the list. Here, we are storing every value, every element in the list in turn into a variable so that we can print it out or do something with it. And you'll find this syntax in C++ and Java and a lot of other languages. And they've been added over the years. So sometimes the values stored in an array should be constants. All right, we've been doing that, right? Because that is a constant, really. It's not stored in a variable, right? It's just a string that's right there, otherwise known as a literal. So it's an unnamed constant. So is that one? Okay, we just put 3 constants into an array. Do you have to do that? No, we could ask the user for those values. What are your 3 favorite colors? You know, and then let them type them in. But sometimes you want to put constants in there. So you can use a constant as a subscript to the array. But that's kind of like a big deal because you can use any variable as a subscript to an array as long as it is a whole number, as long as it's an integer, right? So if you say Indiana is equal to 5 and then you print out sales array Indiana, then sure enough, it's going to print out element 5. The advantage to that would be, I'm not going to even talk about advantages of that. Sometimes you need to search through the entire array to find a value. That's called a linear search. You start at the top and you go down to the bottom. For example, some mail order business where the item numbers are 3-digit non-consecutive numbers. The customer orders an item, so we need to check to see if the item number is valid. Create an array that holds valid item numbers and then search the array for an exact match. Yeah, I'm not liking where this is going. But let's give an example of searching an array for a value. Let's declare another array. Names is equal to, and then just stick, 4 or 5 names in it, right? So between the square braces, using quotes, Joe, end quote, comma, and I'm going to put them in alphabetical order. Alice, end quote, comma, Bob, end quote, comma. You can put your own names in there. Carol, end quote, comma, Doug, end quote, comma, and Evan. So there are 5 names in there. Our possible index values are 0 up through 4. So let's ask the user to tell us a name, and we'll find out if that person is enrolled in our class. So choice is equal to input search for what name? Question mark. And now we need a loop that's going to go through our code until it finds it. We could use a for index loop. We could use a while loop. Y'all do have the idea that the for loops and the while loops are exactly the same, right? There's nothing you can do with a for loop that you couldn't do with a while loop. So I'm just going to go with the for loop. Hope that makes sense. So I'm going to make a variable called found. And I'm going to set it equal to false. But if we ever find it, I'm going to set it equal to true. And then so for I, well, we could do the shortest one. For E in names, right, we're going to use a for each loop. If the choice is equal to that element, then set found equal to true. And then print name found, question mark, end quote, comma, found. Maybe writing it as a for loop obscures exactly what we're doing. Maybe I should redo it as a while loop. But anyways, okay, count up or down. Down in here at the bottom, it's asking me for a name, even though we can't see it. Search for name. I'm going to look for Bob. Bob was in fact found. If I run it again and I look for a name that doesn't exist, hopefully it'll say false rather than true. Search for what name? Chad. Chad was not found. So if Chad was not found, we could ask the user, you know, do you wish to enroll this user in the class or whatever you needed to do? Do you wish to correct yourself? This is what's known as a linear search. Just start at the beginning and keep going. Now you could optimize this code a little bit. I think we talked about the break statement. Once you find it, you don't need to keep searching anymore, right? Once we found Bob, we didn't need to keep going all the way to the end of the list. What if the list was 10,000 items long and we found it on item 3? Would we want to sit there and wait while it checked items 4 through 10,000? No, so we might want to add a break. Okay, so I'm going to rewrite this little bit of code as a while loop, hoping that, you know, by seeing it twice, it'll trigger in our brain. We'll lock it in. So again, I'm going to reset my found variable equal to false. I'm going to declare my index counter equal to 0. I is equal to 0. And I'm going to go while I is less than the len of the names list. And then I'm going to check. If choice is equal to names subscript I, then found is equal to true. And then back tab one so that we can add one to I. Remember, anytime you have a while loop, you need to update your variable. So back tab one and then do I plus equals 1, something like that. Now those two chunks of code are the same. Eyeball them. Hopefully you see why. It's just that, you know, with a while loop we have to do a little more upkeep, right? And this is using that shortest of all possible syntaxes, right? This is using the for each syntax. This is using the longest syntax. Well, same idea though. You're starting at the beginning and you're going out all the way to the end. Now, does Python give you a built-in function for doing that? Yeah, it does. We don't have to write our own loops usually in this kind of language in order to just determine to see if something is on the list. But you have to have that idea in mind. Just like you don't normally have to write your own function that'll add up all the numbers in a list, but you need to know how to. You need to have it, you know, locked in your brain. Start at the first, initialize my, you know, my total variable, add each one to it to my total variable, you know, that kind of thing. I never actually ran it to make sure. It'd be a good point to walk around, make sure we're all doing okay. I'm going to look for Chad. Chad was not found. Okay. Remember, whenever you test something, test it both ways. Give it valid data and then invalid data. So I should run it twice. I did it with Chad. It said false. And if I run it again and I look for Evan, it should say true. And it didn't. I got an error. What did I do wrong? Well, blow me down. Alrighty. Did it work the first time and not the second? That's my first question. So I'm going to take that print statement and put it up here above my while loop so that I can see if the first one worked and then the second one didn't. I wish I hadn't made this mistake because now I'm going to waste precious moments trying to figure out what I did wrong, but it's a learning experience. Okay. So that's all I did is I moved that print statement, I copied it and pasted it above the while loop so that I could see if the first loop worked. All right, so the first one worked, the second one did not. I need to eyeball and see if I can figure out why.
Two equal signs. Which one?
Sorry?
Isn't the two equal signs after found equals true?
Ah, you're right. You're right. Take a point off my exam. Thank you. You use two equal signs when you're comparing. You use one equal sign when you're assigning. All right, that fixes it. So make sure you only have one equal sign there. And that's why you test both ways. You know, I ran it and I was sure it was going to work, and it didn't. All right, that tells us if it's in it, but here's the Python specific way of doing that. Because like I said, you know, why if the language gives you the ability to do it in one command rather than in 10, you're going to want to do it in that one command. On the exam, I'll probably ask you to do it in the long way, but something like this. Found is equal to, and what we're checking for is choice in names, like that. So, whoopsie, where'd that go? What did I just do? Okay, there we go. You just use the in syntax, in. Or, you know, something like this. If choice in names, colon, print, yep, I found it. That kind of thing. Else, colon, print, nope, not in list. I think I'm going to delete this found equals choice in names. The reason I had it is because it exactly duplicated this code by creating a found variable, but I think that this syntax is clear, right? Just doing that. Okay. So this one line of code here, choice in names, replaced all this code. And that's because Python gave us some functions to use with lists. Gave us a lot of them. What if we wanted to sort our list? Now my data is already sorted. I don't necessarily need to do that. Let me see if I get this right. Names2 is equal to the sorted version of names. Is that going to be an error? Probably. Let's run and find out. Yeah, that was wrong. Okay, so it's probably names.sort. Names.sort. So that was not a syntax error. I could print it out now. You know, I actually made my names in alphabetical order already, so it's not going to be a miracle that they're sorted, right? But just take it on faith. If I went up and I changed some names, you know, then the first list would not have been sorted. The second one was. And I get none rather than actually getting something useful. So I have broken this. I'm wandering off the rails. Oh, I don't store its value. I just do this. Names.sort and then print the names. That sorts it right there. Sorry for making it harder than it needed to be. Sorts the list. Now, why would you want a list to be sorted? Besides the fact that it's prettier, right? You know, humans like to see data sorted when it's displayed on the screen or whatever. It can speed up searching for a value, right? If we wanted to see if Chad was in a list, if it's in alphabetical order, as soon as you get past the word Chad, like if you start hitting names that begin with D, you can bail out right there. So you don't have to keep searching all the way to the end, as you have to do on a linear search. If the data is sorted, then you can just keep going until you find it, right? And then if you go past the point, if you start hitting names we're looking for Chad, but we find names that are higher than that, you know, Darren, you know, Eric, whatever. Once you get into the D's and E's and F's, you know, you've gone too far, so you can break out of the loop. Even better, if the data is sorted, you can do something called a binary search rather than a linear search. A binary search is when you start at element 0 and you go all, excuse me, that's a linear search. A linear search, you just start at element 0 and you go all the way to the end. Linear meaning a line. You just plow a line straight through it. Binary means that you break it into the middle, just like our guessing game, right? You guessed 50, and then you guess 75, and then you guess 63 or whatever. So if you have a list and it's sorted and you're wanting to find that item, you go to the middle one, right? Is names, subscript, you know, whatever, 50, is that right? No, it's not, so I need to go to name 75 because my value is larger. Nope, that one was too large, so go to 63 or whatever. And you could write an algorithm that would do that. And so it's a binary search. Once to the middle of that, to the middle of that, you know. And that way, instead of going all the way through it, checking all 100 items, you know, it'll take at most like six pops around to do a binary search. Just like it should take at most 6 guesses to guess a number between 1 and 100 if you execute that algorithm perfectly of always picking a number, you know, halfway between the start and the end. 50, nope, it was supposed to be smaller. 25, nope, it's supposed to be larger. 37 or 38, nope, it's supposed to be smaller. You know, you can zero in on it like that, a maximum of 6 or 7 times. And I've forgotten the equation that shows exactly. But okay. So the ability to sort the list is nice. What if we wanted to remove an item from the list? Okay. I guess I should make a notepad saying that we are wandering off into Python specific stuff here. We're going to say that our list is L. Well, we could go ahead and type this in here. Just make L, capital L, is equal to, and then let's put some numbers in there. 8, 6, 7, 5, 3, 0, 9. For you guys who like 80s rock. 8, 6, 7, 5, 3, 0, 9. Alrighty. I want to remove the 9 from that list. No, I want to remove the 0. I don't like zeros for some reason. So L.remove, get rid of that 0 for me. And then let's say I don't like that 8 there. I think I've done this in the wrong order. Let's print out that list to see what that did. Let's see if that actually worked. I'm curious about which number actually gets removed. I want to find out if it found the 0 and removed it, or if it removed the first element, the 8. So let's find out. Eight, 6, 7, 5. So that removed the specified value. So dot remove removes the specified value from the list. What if we try to remove a value that doesn't even exist, right? We have 8, 6, 7, 5, 3, 0, 9. Do we have any 1s in there? No. So if I change that to L.remove 1, I'm getting tired of having to answer all these questions every time I run it. It blows up because it couldn't find that value. How could you fix that? You could do something like this. I'm just going to put it in as a comment. If 0 in L remove, or L.remove 0. Right? We're just checking to see if that item is in the list, just like we did up here. Was our choice in the names list? Yep, I found it. Is that value in our list? Great, remove it. That's one way to do it. The other way you could do it is to delete based on its index number. What if you want to delete the first element of the list? Delete L subscript 0. And then let's print our list one more time. Okay, did you see the difference between what the two things did? The first remove took out, it searched the entire list, finding that 0 and deleting it. The second time it removed element number 0, element subscript 0, which is the first one, so they ain't went goodbye. So I do want to keep track in a little notepad though. So if you have a list L.sort will sort the list. L.remove value will remove the element with that value from the list, and then delete L subscript whatever your index value is will remove the element at the specified index. Now you understand that an index has to be a number, right? But the value could be anything. If we were going to remove Evan from the list, it'd be L.remove parentheses Evan, you know, parentheses quote Evan, whatever. So we had our names list up here, way up here. I'm going to print my names list again, and then I'm going to remove one item from it. So print the names list, and then I'm going to ask who to remove. Choice is equal to input. What name shall we remove? And let's make sure that it's in the list first, because if it's not, then trying to remove it would be an error. So if choice in names, colon, great, let's remove it. L.remove our choice. Else, let's tell them that the name wasn't in the list. L.remove parentheses choice into parentheses, else colon, print, your choice isn't in the list, is not in the list. And let's print the names list one more time after we perform that action, just to make sure it worked, right? So count up or down, up, Evan, great. What name shall we remove? I'm going to remove Doug. And it blew up. Surprising, because we did confirm that it was in the list, did we not?
Would it be names.remove? Since L's
Oh, for Pete's sake, you're correct. Right. Thank you. I want to remove it from the names list, right? So where did I come up with L.remove? That was our list of numbers. So change that L.remove choice. Thank you so much. I was getting very frustrated. To names.remove. All right, and so after I ran it and I printed the list again, I removed Doug. Doug is actually not in the list. So another quirk about Python is that if you want the last element of a list, you can just use index -1. If I wanted the last element of my names list, here's how I would do it if I didn't have that option. So print the last name is, end quote, comma, and this is going to be tacky syntax here. Names at subscript or index, and inside those square braces, len of the names into parentheses minus 1, and then a terminating semicolon. All right, now that's pretty nasty syntax. I mean, it's not that bad. But if there's a syntax error in what we've typed along so far, it's probably going to be this one. Make sure you get the square brace right. Make sure you get the opening brace, parentheses, closing parentheses, a closing square brace, and another closing parentheses. That's one way to do it. Here's the faster way, the easier way. You just use -1 as your index. Print the last name is, end quote, comma, names, index, -1. Name, square brace, -1. In square brace, in parentheses. All right, I know which one I like better. But not all languages support. In fact, Python's the only one I've ever seen do it that way. Where you can use -1 to get to the last one. So if you have 4 names, -1's the last one, -2 is the next one over, -3 is, the next one over, and -4 is, the first in the list. Kind of a weird concept. But I do like to remind people that if you need to check the last element of the list, you can get to it that way in this particular language. Okay. I'm getting real used to typing those answers up, Bob and Bob or whatever, but I'm getting tired of having to answer those questions each time as well. So a few more notes. The index values can be from 0 to the length of the list -1. Or in Python, if you use negative indexes, index values, it starts counting from the end. So the last element is at index -1. The second to last is element -2, and so on. So I can ask you a question like this. Print the first and the last name in the names list. And how would you do that? Well, you could do this. Print names subscript 0, that gets the first one, right? And then names subscript -1, that gets the last one. Matter of fact, that's so fun, I'm going to go ahead and type it over here. So print names subscript 0 in subscript, comma, names subscript -1 in subscript. And there we have it. Alice and Evan, first and last. What if you have a list and you want to put a value onto the end of it? We need a new name. It's .append. Names.append William. I'm going to append a few names. Names.append, and I'm going to put them all out of order. Sam. And then I'm going to sort them so that they will be in order. Names.append Harold. All right, great. I added 3 names, and now I want to sort them. Names.sort. And now I'm going to print them out. Print names. And we look at it as, in fact, sorted. Harold comes before Sam, who comes before William. Anybody need help correcting red text? Alrighty. Alright, so we've seen several different things. You can add to the list, you can sort it, and you can remove, and you can... There's actually two kinds of deletions, right? If you remove it by value, you can, or if you want to delete it by its index position, you can. Either one of those works. And so I'm going to go ahead and in my notes, I'm going to mention that .append will append to the list. I'm going to change that X to the word value, just like we have here. Okay, so these are Python list operations right there. And I'm going to want you to have those fairly well committed to memory. So we'll make a point of talking about them again. Okay, something I don't think that I've shown y'all very much is the idea of a formatted print statement. And I do want to go ahead and mention that. And I'm tired of answering all these questions, so I'm going to put it up here at the very top. Right? So I'm just going up to the very top of my code. Let's say that I have a first name equal to Joe. I have a last name, that's an L, not a 1, equal to Williams. And his age is 37.53. This is stupid, but okay, just go with it. 5432. So what I can do is I can use what's known as a formatted print. And the way you do that is you use percent symbols to create placeholders that get filled in. Like %s is going to be the first name, %s is going to be the second name, and then %f for the number. So then F name, okay, sorry, I need to modify my syntax a little bit. After the end quote, don't put a comma. Instead, put a %sign, and then parentheses, and do F name, comma, L name, comma, age, like that. And then one more close parentheses. All right, we're going to mess with that syntax again. Print first name equals %s, comma, last name equals %s, comma, age equals %f. Now the S means string. These are strings because they're words. F means floating point number. All right, so we have all of that formatting string. Put an end quote, a %sign, and then just all this stuff again, right? Just copy and paste that. All right, so it worked. You see what it's doing? It's filling in these placeholders with data. F name goes into that one. L name goes into that one. Age goes into that one. How does it know? Well, it just fills them in order. You know, the %signs in this case mark the placeholders. What that lets you do is it lets you get specific about how many characters wide you want that name to fill. Right? We could print the first name and pad it out to 20 characters. We could print the last name and pad it out to 20 characters. We could print the age and pad it out to 20 characters. Why would you do that? Well, what if you're printing, you know, a table and all the names are of different lengths? If you didn't have the ability to specify how many columns, how many characters wide they were, you know, then your data would snake left and right, and it wouldn't be cool. So let's play with that. Copy that line. And let's say I want first name to occupy 20 spaces. So first name equals %20s. The last name is equal to %20s. And the age, I don't care how many spaces it fills, but I only want it to have one decimal point. So %.1f. because we declared his age out to 4 digits, but that's kind of silly. We don't need to know anybody's name out to four decimal places. All right, so it's a little bit too much space, isn't it? Right? But the first name is Joe, the last name is Williams, and the age is equal to 37.5. That's a formatted print statement, and you use those for making tables, reports. Let's just do a nested loop, but we're going to use formatted prints to make the data look better. So we're going to make, a little multiplication table. So here's our nested loop. For x in range 1, 11 by 1s, for y in range 1, 11, skipping 1 every time. And remember, if you leave off the skip number, that comma 1, it automatically goes by 1s. So I could remove those. And then let's print out x times y. After we print out a row of numbers, we're going to want to print out a blank line. Okay, this is going off the rails here. This is doing more than I actually wanted to do. But since I started it, we're committed. There is, let me show y'all something. What if I didn't want to go to the end? What if I didn't want to start a new line with every print statement, right? If I do this, I'm going to stick this code up at the top. Print, Python, and then on the other, and then I do programming, right? It's going to print those on separate lines. What if I want them on the same line? There's a parameter to the print function you can use. That the END parameter. So here's what I'm going to do. For the first one, I'm going to say Python end quote comma END equals quote space quote. Don't go to the next line. Just add a space. That's all I want to happen. And now when I run it, it's going to say Python programming on the first line. All in one line. Right? Well, I got all that data here. But if I look at it, it says Python programming all in one line, and we're real familiar with the idea that if we hadn't have done this, END is equal to space, END is equal to that it would have been on 2 separate lines. So we're going to do the same thing down here. So print x, I'm changing this line now, and this will be the last thing we do today. END is equal to quote space quote. And let's see what it does. It's not going to be the right thing yet, but it's getting closer. All right, if I wanted my little multiplication table to really be pretty cool, I need it to stop at that line. It needs to go to the next line, right? We don't want all of this out on one line, which is what's happening right now. So we have our outer loop here, and we have our inner loop here. When our inner loop is done, we want to print out we want to go to the next line. So I'm going to add an empty print statement there. Okay, that's pretty neat, but we could make it look a lot prettier, couldn't we? If I had to do math and I had to use that table in order to figure out what 6 times 7 was, I wouldn't enjoy looking at it. What could we do to make it prettier? We could make all of them the same width. That's what we ought to do. So we're going to need to change this statement here. I'm going to comment it out and retype it rather than just edit it. So print %3d. Why d? Because it's an integer, not a floating point. End quote, comma, not comma, % x times y. And I forgot to put the x times y in parentheses of their own. And then after all that, comma, END is equal to quote, space, quote, and then a final parentheses. Now that looks kind of nasty, right? But the end result's going to be pretty. Sometimes the result is worth all the extra trouble. You see what I mean? When I ran it, all of the data was nicely lined up. We could actually use that as a multiplication table, right? 3 times 4 is 12. You know, 6 times 6 is 36 or whatever. So that we used a placeholder here. We used a formatted print. This said fill in the placeholder. It's going to be a digit. It's going to be an integer number. And I want you to make sure that it's 3 spaces wide. And if it's not 3 spaces wide, it adds spaces onto the beginning of it to make it look good. Which is what happened here, right? It printed out 1, but 1 did not occupy 3 spaces as specified, so it added a couple spaces to it to make sure it fit. All right. I just wanted to introduce that idea because when we come back, we're probably going to do something that prints a table which are lists of data, like lists of first names and last names and ages and favorite food or whatever. You know, they're graded in the class. And we want them to be tables, so we want them to all be lined up. And to get them to line up, we're going to have to use that percent syntax. Alrighty. Let's make a Dropbox. Then I'll wander around and help those who need a little bit more help.